Hi everyone, welcome back to our channel. I hope you all are sound and safe. Hi Sejal, hi Luck, hi Obesi, hi everyone. Make sure you drop in your name and the country name you're tuning in from, just like I'm going to drop mine. So my name is Vivek and I'm tuning in from India. So everybody make sure to drop in your country name or your region from where you're joining us. Good evening, Rajvi. Hi Swarnam. It's so nice to have you all back. We will be starting our session in another 2 minutes. So by that time, I request all of you to please make this session as engaging as possible. Hi, everyone. Hi, Marco. Hi, Mala. Swarnam. Hi, Swarnam from India. It's so nice to have you all here. I hope you all are doing well, enjoying the weekend. Hello. All right, we will be starting our session in another just 2-3 minutes. By the time I request you all to make this session as engaging as possible. We will be going through a lot of things and we will be learning some new details or getting some new details by our master trainer whom I will be introducing very shortly. Details about track 2 specifically, how exactly you can make your own robot and what all you need to learn about that particular thing, mechanisms. Hi, Tejushri. So I think it's the right time to start off today's session. Once again, a huge welcome to all of you. Myself, Vivek from Codeavour management team, and I'm thrilled to welcome you to this exciting session on learning robotics mechanism for building combat robots as a part of Codeavour 6.0 International. Today, we are diving into the fascinating world of robotics and mechanism, where creativity meets engineering. In this particular session, we are going to talk about how exactly robotics works, how exactly mechanism works, and we're also going to explore how we can transform our innovative ideas into a fully functional robot. So, our master trainer, whom I will be introducing very shortly, will be going through how exactly you can use different types of mechanisms and what are the science behind those mechanisms that you can use to create your own robots for track 2. So, as you know, Codeavour has always been about pushing boundaries, fostering innovation, and inspiring young minds to solve real world problems creatively. With that particular spirit, we are here to guide you to an incredible journey of learning, creating, and building together. So, let me give you a quick walk through the session itinerary. So, we will go over tracks overview, in which we will give you a snapshot of the various themes and challenges that are available in this competition. Then we will dive into the introduction to the mechanisms and also discuss the different types of it so that you can choose the best mechanism that is required for your robot mechanism that you will be building. Following that, we will be also having an introduction to the the creator kit, which is there, which is one of the ultimate tool for building innovative robots. And then we will be also discussing more about track 2. So for that, you have to stay with us till the end of this session because we will be sharing a lot of details. We will be sharing you what are all the challenges and also telling you from where you can get the access to the learning resources of track 2. So basically, we will be wrapping up by providing you insights and guidance to help you to align your projects with this specific track. So stay tuned till the end to know more about the same. And as I mentioned, it is going to be a very informative session. So yeah, now is the right time to introduce and welcome the master trainer of today's session, Mr. Dhruv Radani from Codeavour team. With his expertise and passion for robotics and innovation, Mr. Dhruv is here to guide us through his exciting journey of building combat robots. So get ready to explore, learn, and create under his mentorship. Over to you, Mr. Dhruv. Mr. Dhruv, you're on mute.
Thank you, Vivek. Yes. Good evening, everyone. It's an exciting evening. We are going to learn lots of things today, right? How we'll make our robot more challenging. So let's have a look at our session and let's have a look at exciting mechanism, new mechanisms. It might be new for you, or it might be somewhat insightful, which I will show you a different thoughts you will put in in your mechanism and robot, so you can make a more interesting and more uh, challenging robots, right? So let's have a look at our session. So this time in Codeavour, we have two tracks, as you all know, right? So first track is innovation and entrepreneurship track, where you will be showcasing your unique and innovative ideas. And track two, climate action challenge, where a physical competition, your robots are going to complete a lot of tasks which will be predefined and compete with other, right, within a limited time. So both the tracks present the opportunity to create exciting robots that can perform various tasks like lifting goods, dispensing product, collecting waste, locking doors, and so on. So if you are from track 1, this session is also going to helpful for you, as you are going to know the lots of mechanism which you can also apply in your projects. So let's go ahead in this session. So you all are familiar with this day-to-day life, right? Have you ever wondered how these machines and objects work? How does this bicycle or car move? Have you ever thought about how clock works and how does scissor cut the paper? These all objects around you works on same mechanical principles like pulley, gears, shafts, and so on. Almost any mechanical system you insist in daily, right? So today you will be learning not just about the components, but also why these mechanisms matter, how they function, and what they consist of. If you have participated in Codeavour in either innovation or whatever track you are in, right? This is the best place where you are going to have a most of the insights. So why do you need mechanisms in your project or robot? Mechanisms are the building blocks that enables robot and machines to move, lift, and manipulate objects. Without this, we wouldn't have functional tools or vehicles or robots, right? You all have showcased amazing project in Codeavour 5.0 using different mechanisms. You have example on your screen, right? So complex or simple, all works on basic principle, right? Mechanical principle they have. So let's have an example of our track 2 and let's understand how mechanism works. So let's take an example for understanding how how to make a robot that can pick an object and navigate a complex path. You you need to figure out the appropriate mechanism which makes it happen. And today we'll explore which one will be helpful for you. So we'll break it down in multiple parts and we'll see where what mechanism will be used to make your robot. So first of all, let's have a look at the building blocks that will be used to make your robot. You need to have a frame and chassis, a main structure that supports all the components and provides stability. The second thing is sensors for the detection and the actuators to respond. And third one is mechanisms and end effectors, uh, uh, which acts as a robot, which helps a robot to perform tasks. At last but not least, at least you will need some kind of controller like Quirky or EY, right? Which will be the brain of your robot. Uh, for track one, it can be EY, but for track two, it's just for Quirky. Mind that. This will be controlling your robots for the programming. Can everybody guess what sorts of robot what sorts of tools and machines are used to lift objects? For example, you want to lift any kind of objects on track 2. So what kind of tools or machines you will be taking as an example to implement in your robot, right? So what real life example? I'm asking for a real life examples around you which are capable of lifting tools and whatever objects around you, right? So let's have a look at the chat. Put your answers in a chat.
Right. So we are waiting, everybody, for your answers in the chat box. Let's make this session as engaging and active as possible. So,
Just
Mr.
give an example which whatever machines you look around you which are lifting something and yes, lifts or yes, specifically lifts. Yeah,
So
lift
we
is a
have
good example.
forklift,
Ah, that's also good example.
crane.
Yeah, correct. Yes, that's a good answers. Let's have a look at examples. Here are the few examples from my side. For example, construction cranes, which uses the pulley mechanism, right? So hydraulics, scissor lift at airport, right? So the second example is hydraulic lift, which has a scissor mechanism. You will be looking at this kind of lifts in the airports. Then there is a car jack, which functions using a screw mechanism. When you rotate using a rod, uh, the screw mechanism functions and your car lifts, right? And the last example is of a camera crane, which have a lever mechanism. So let's have a look at each mechanism and how it works. So our first mechanism is lever mechanism. You all might be played on this instrument, right? Seesaw. So have you ever wondered how seesaw works, or what happens when your younger brother sits on another side and you are smaller and you have less weight and you are on the second side? What happens at that time? You all might be thinking like you will be on the sky, right? So lever mechanisms are basic. It's a very basic mechanism. It has a crossbar. It has a three components. So let's have a look at it. So when how lever works. So here there is a fulcrum, which is the base of this mechanism. Then there is a one what we call the link in on fulcrum, which is connected to a fulcrum using a joint. And there is another there will be a load on another side and you will apply a force at different side. So let me show you the first example. Here you can see the fulcrum is more to the more towards the load, and the your link has a uh, and your link is too much towards your and the link has a lots of short distance at a load side. So when you apply force on this side, you will need to apply lot of force to pick up this load because the fulcrum is more towards the load. And when the fulcrum is in middle, you will apply at equal force to pick up the load. And if when you need to when you have a lot of force and your load is very light, you can use this kind of setup. So when you will apply the force in this side, your load will be easily lift up. But if load is heavy, then it will be much more difficult for you to lift in this situation. So second one is scissor mechanism. So in scissor mechanism, you have this kind of examples. As I said, airport lifts, and you might have played some kind of toys which might be functioning using scissor. This is an example of a toy which is grabbing a ball using a scissor mechanism, right? So this is how scissor mechanism work. Let's see how it works when you tweak it. So these are the two example. Both of them has a different motion, right? The second one has a tweaked uh, joints. So when you in first example, if your pivot points are in center between links, then your motion will be linear towards straight, and linear and straight towards one direction, right? But when you off center your pivot points, what happens? Your motions changes. It will be a circular. So it might be helpful for you in some condition where you don't have a clearance in a straight, right? So you can use this mechanism to extend some kind of parts in your robot. So that you can grab something, or you can uh, complete a task, or you can hit something, right? If you have this kind of mechanism in your robot, it will helpful for you for this kind of task. Let's have a next mechanism. It's a pulley mechanism. You all have answered lot in my first question, that crane and lots of things, right? So this kind of cranes uses a pulley mechanism. So what pulley mechanism are made up of? So for pulley mechanism, you need a rope or something flexible strap, right? Then you will need a pulley, which is the main component for this mechanism. And there is a load, which you will be pulling using this whole mechanism. So you can see this kind of mechanism in cranes. You all have answered and figured it out. So these two kind of pulleys are there. So first example, you can see there is a load and there is a one pulley, and force is applied in this direction. So for example, your load is of 4 kg and you want to pick it up. So you will need equal 4 kg or more force to lift this thing. If lift your load, right? So this is known as a fixed pulley system. There is a one pulley which is fixed. Load at a second load is hanged on a rope, and you will need more uh, force than your load's weight to pull this load. In second in second type, there is a two pulley. So what happens here? In this system, you need half of the force to lift your load, because it's dividing between two pulleys. So what happens when you apply a force, your load will be lifted slowly than you lift in fixed pulley system, but you will need a very less force to lift your load. You can also multiply or add more pulleys to pull your very heavy objects slowly but easily, right? So this kind of also mechanism you can use in your robots to lift something. You might have a magnet on another side which might be sticking to objects and picking something, right? So this kind of mechanism also works for lifting objects. Also, you can make something functional. For example, instead of load, you have some mechanical link linked between these two links, right? When you apply force, what will happen? Pulley will pull the second link, and your link will get closer to each other. So this way also your two links can function. So pulley is not only to lift any object, but you can also make some different kind of functions using pulley and pulley mechanism. So these all were the mechanical uh, mechanisms which were used to lift objects mainly, right? So now can you think of other mechanisms you might use to perform actions like steering, pushing, or gripping using your robot? Put it down in a chat, live chat, so that we can know if you have answer. What other things you can use? We have finished a chapter for the uh, gripping object or a lifting object. But for other functions like steering your robot, pushing something using your robot, or gripping something using your robot, how can you make that kind of things? Do you have any ideas? Or if you have any kind of examples, drop it down in live chat so that we all of us can know. Yes, love. Okay, so let's have a look at more mechanisms which will help you to do this kind of more actions in with your robot. Yes, the one answer is using gripper robot, right? But gripper robot is made up of group of objects which functions as a mechanism, right? For example, let me take you through an example. Let me give you one example. Have you seen our quirky pick and place robot, right? So pick and place robot has a mechanism which functions in certain way so that your cube is picked up using a quirky. So let's have a look at that kind of mechanisms and how can you make that kind of mechanism by yourself. Let's understand that kind of mechanisms. So first one is a 4-bar linkage mechanism. You have seen, have you ever wondered like how cars wipers work, right? So this is the mechanism behind your car wipers functions. So what happens when one link is rotating, the second link is oscillating. So this oscillation functions is made. This oscillation function is helpful for the car wiper to work. So basically, 4-bar link mechanism is made up of four links as per its name: one, two, three, and four. So let's have a look at kind of 4-bar link mechanism and how it changes its function as per its type. So there are majorly three types for this 4-bar linkage mechanism. So first type has a one. Let's understand the parts first. So there is a base for this mechanism, and there is a driver, which is attached with which might be attached with any kind of motor or actuators. Then there is a coupler, and there is a follower. Follower is your part which will be showing actions, right? So in first example, we can see the driver is rotating in one motion, right? And coupler is linked with follower, and follower is oscillating. So this kind of mechanism is known as crank rocker. So basically it's a crank and it's rocker. So it's rocking and its crank is rotating in one direction. In second example, we can see that both crank both are the cranks. Why? Because driver and follower both are rotating in same direction. So this is the example. And the last type is a rocker. In this example, we can see both links, both are connected using a coupler. One driver and follower both cannot go beyond this point, and they need to rock in one direction. They oscillate in single directions, right? This way. So these are the examples. This kind of mechanism you can also use in your robot for different tasks or for functions, right? Then the next mechanism is our parallel joint mechanism. This is very common mechanism. You have seen this kind of mechanism in our quirky robotics kit. if you have seen. If you don't have seen, I request you see this our kit on YouTube or somewhere. You will find our videos, right? So it's interesting mechanism. This will be a lot of this mechanism will be lot of helpful for you for making robot. This mechanism also you can see at a camera, like a movie camera setup, right? So what is the purpose of this mechanism? Let me make you clear. So this mechanism, what does this mechanism? There is a one link which is fixed, and you want another link at different point which works parallelly, doesn't change the angle, right? And it also has a motion in different way. Like for example, in this camera example, it will move up and down. Camera will move up and down, but it won't change the angle or degree of the this camera, right? It will be as parallel with this base link. So this is how parallel joint mechanism works. Also, you can see this mechanism in steerings of car. You if you have a toy car which steers, it will have this kind of mechanism which will be functioning inside your toy to rotate your wheels, both the wheels, front wheels, in a certain degree. So in the principle behind these mechanisms is all the links are parallel to each other. For example, link 1 and link 2 will be always parallel to each other, and base 1 and base 2 will be always parallel to each other. It will change the distance between both, but it won't change the its degree. Okay, so this is the key point for this mechanism. Then let's have a look at next mechanism. Yeah, by the way, if you have any questions, we will be having that solved at end. Okay, so keep that question in your mind or list them down. We'll be discussing at the end of the session. So our next mechanism is slider crank mechanism. So this mechanism you might have seen in steam engines. Also, you might have seen this in sewing machines where needle will be moving up and down, right? How does this function? So this is the mechanism which is functioning behind this all machines. So let's have a look how it functions. So for this mechanism, you can have a link for main as a main crank, or you can have a wheel kind of or any gear type of thing in your mechanism which is behaving as a crank. Crank is let me clear you. A crank is something which is connected with actuator or motor, right? And it applies a force to whole mechanism. So crank is here at this point, which is connected to a slider using a link, and your slider is fixed between a frame. So what happens here? Your slider don't have any multiple direction to move. Only there is a one direction to move. As crank rotates, link will push it and pull it, right? And this function will complete. So this kind of mechanism will be helpful for you for the task where you need to push something, right? Or you need to pull something maybe, right? Or you might need this kind of also mechanism used to lift your robot. For example, let's have or imagine this mechanism as a vertical, right? So when this slider slides down, your robot might be lifting itself, right? This can also happen, or you can make it happen. So now let's have a look at our next mechanism, which is rack and pinion mechanism. You all are familiar with automatic doors, or maybe dam gates, right? You might have seen this kind of machines attached at automatic doors, and this kind of link, right? Which we will be calling as a rack, and there is a gear which is known as a pinion. So pinion and rack, this is how this mechanism is named, and it also functions in same way. So what happens here, when pinion moves, then rack will be showing us a motion in a uh, two direction, either forward or either back. And if you move a rack, your pinion will rotate. So you can apply force at pinion or at a rack, and this mechanism will work. So if you want to rotate something using a rack, or for example, if your robot is attached, your robot has a rack which is coming out right of your robot in the front side, and if your robot touches a wall or pushes against a wall, your pinion will rotate and some action will happen. That kind of thing, if you want to put in your robot, you can use this kind of mechanism. Or if you want something like a slider mechanism, this mechanism also, you can replace this mechanism with slider mechanism, and you can also make something to push using this mechanism. So when your motor rotates, rack will be pushing some objects away from your robot, right? So this mechanism also be applied on your robot to push or pull something. Or your robot can also expand using this mechanism. For example, your robot has two racks and two pinions, and it's all your robot is completely like a drawer, right? Like slider. So what happens when pinion rotates your on rack, your robot is expanding. So that kind of also thing you can do in within your robot using this rack and pinion mechanism, right? So that's all for that were all the basic mechanisms. Now, have you ever wondered what essential elements make mechanism work? How mechanism works? Have you ever wondered what is the key thing which mechanisms need? If anybody knows, please drop it down in live chat so we can know who is the smartest in this session. So mechanism has lots of different parts, right? What another thing which mechanism needs to function? Without that, mechanism is not possible. Anybody? Okay. Fulcrum. Yeah, fulcrum is something, yeah, but what is like more than, it's not much important. Without fulcrum also, mechanism work. You can make some mechanism and make it work using your hands, right? Fulcrum is a key, but there is something more important than fulcrum. Apply force. Yeah, yeah, force is necessary in mechanism. Okay, let me tell you. It's a joint. Without joint, you cannot make your mechanism, or it won't function, right? So the joint is the key point for your yeah, gear and everything. Yeah, good answers. Basic education, Marina. Yeah, joystick are the good answers. Yeah. So here, joint is the key thing which you will require for your mechanism to work. So when you apply different kind of joints, your mechanism completely changes, right? When you have a rotatory joint, your mechanism will work in that way. If you will fix both two parts, your mechanism won't work. So joints are the key thing for this. Let's understand what kind of joints are there. So first type of joint is rigid joint. This is a very basic, and you all know how can we join something which is permanently fixed, right? So you might have glued something using glue, For example, here you can see two piece of wood is somebody is gluing two piece of wood using glue, and this is known as rigid. Also, welding is a rigid joint example. Also, when you join some two uh, objects using nuts and bolt, multiple nuts and bolts, and it doesn't allow them to move in any direction, it's known as a rigid joint, right? So there is a no motion, there is a no it's basically it's not a joint which allows function, right? So this joint is used to make some stable structure for your robot. So when you want something stable, this kind of joint you will use. So next is a revolute joint. This is also common. You will need this joint at multiple points of your mechanism. So where revolute joint is a joint which allows a rotation in fixed axis, right? For example, here robotic arm has a multiple points where revolute joints are applied, and it allows two links to rotate in a fixed axis. Here are the more example how you can you make using creators kit. And remember that you use lock nut with your nuts and as a nut and bolt, right? So that your revolute joint doesn't get loose. For example, if you are using normal nut, what happen when you will be when your robot will be functioning, or when your mechanism will is at function, that normal nut will be loosen, will be loose, right? So apply, always use a lock nut where you want to apply revolute joint. This will be helpful for you, and your joint won't lose at any point of time. Then the third one is a cylindrical joint. So this is similar to previous joint, but what happens here, one more axis adds up. There is a rotation, right, as per revolute joint, and there is one more direction where the action is happening, which is linear. So with linear, there is a rotation. It's known as a cylinder joint, right? So this kind of example you can see as a see at a telescopic antennas, right? Where you can extend your antenna. Also, you can rotate it. So linear motion is also happening, and rotation motion is also happening at that point. So this kind of joints are known as cylindrical joints. Also hydraulics at your maybe in vehicles are also at same principle. Like if hydraulics has a rotation at second point, and also it expands in a linear motion. And also injection is also good example, where you can see that when you push at some it says at one direction, you can also rotate, right? So injection is a good example for this cylindrical joint. And you can also make any kind of mechanism using injections in your robot, right? Using water and tubes connected at another each other, right? Lots of you in past, I have shown you example of past Codeavour, in which one guy has used injection for this kind of joints, basically for this kind of joint, right? So fourth one is a slider joint, in which sliding is happening, right? So here what happens, guides in this slider joint, it guides your links or part in a linear motion. It doesn't allow any other kind of motion, right? So here is the example. Table drawers is a good example for this thing. Then there is a lathe machines and other machines which uses slider. If they have a, sliding bed, it will be a slider joint. You can also see these kind of joints at 3D printers, where bed is moving, right? Sliding at one axis. So at that kind of point, it's known as a slider joint, right? Then the fifth joint is a ball joint. So for ball joint, there are a lot of motions. You have a lot of freedom, so it allows in a multiple direction to move. So here you can see an example that it is also moving in x-axis, and y-axis, also z-axis. If there is any cylindrical joint is applied, then only z-axis, otherwise it's a y and uh, x-axis at both together, right? So this is a ball joint. You can also see example at your shoulder. Your shoulder is a good example of your ball joint. You have a ball joint, right? And also this kind of joint are used at robotic arms for multiple multi-direction movements. Also you can see this kind of joints at cars, right, where suspension and your wheels are attached, right? How does your steering connected with your wheel, right? There is a ball joint between your steering and wheels, which will allow wheels to be uh, multi you use which will allow a wheel to move in multiple direction while there is a shock, right? So you can see this kind of ball joints at multiple point. So, what do all joints need to perform their actions? Right? Anybody? What do all joints need to perform their action? We have seen that all the mechanisms needs a joint, right? Now, what joints need to perform their actions? Can anybody guess? And let us know in chat. Hinges. Yeah, a hinge is a type of joint, but yeah, but what you will need to make a joint basically. Hinges is a joint, kind of joint. It's a type of joint, right? But hinge is made up of what? Force is applied to joint, but joint is made up of what? My question is, how will you make a joint? It's a very basic thing. No, still we are going too high. Just think very basic thing. Very basic thing you will require to make a joint. So bodies. You will need some kind of body, right? Without any some object, how you are going to make your joint, right? At least you will need some two parts, right? Bearing, yeah, bearing is a whole object, and bodies are the basic thing which you will require to make anything. Even joints are made up of bodies. So these four type of bodies are the basic bodies, right? Solid bodies you will use for joints and also for mechanisms. And you will also have elastic bodies where you will need elasticity. You will use this kind of rubber bands and straps which have elasticity, right? For your mechanism or your robot. You will also have one flexible things in your joints or your assemblies, where you will need a flexibility. For example, there is an arm which is connected with a thread, or you in your pulley mechanism you will need a flexible rope, right? So the flexible bodies you will require to make a mechanism and joint work. Then there is a fluid bodies which will be you all will be using for a injection kind type of projects, your projects, right, where you are using injection in which you have a water filled with water filled to function the whole mechanism, right? So these four bodies are the very basic thing you will require to function your all joints, and joint will function as a uh, complete mechanism, and all mechanism will make your complete robot. So When you apply different type, when you combine different type of bodies with different type of mechanism, your outcome will change, right? You can experiment this kind of things at your home. Try applying elastic at your pulley mechanism. What will happen? Let's see, right? So your object which is hanging will also jump, will bounce, right? So different kind of outcome you will see when you will apply, when you will combine this kind of different things with different kind of mechanisms, with different kind of joints. Your outcome will be very different, and you will amazed using these things. That's all from my side. I am handing over the session to Mr. Vivek. They will let you know about further interesting Codeavour things which will be available for you this year. So over to you, Vivek.
Thank you so much, Mr. Dhruv, for that amazing session of yours. And I have to say, even I learned a lot about mechanisms and how exactly they work. So I really believe, I strongly believe that this will help every student who has joined us live today, creating their robotics mechanism for track 2. So moving ahead, please allow me a moment to share my screen. So now is the right time to talk about one of the most amazing thing that we have for you, that is Quirky Creator Kit. So this Quirky Creator Kit is designed to help students build powerful, competitive robots. Whether you all are working on AI or ML track, which is innovation or entrepreneurship track 1, or track 2, which is climate action challenge. This kit will give each and every one of you an edge with advanced robotics mechanisms, sensors, motors, and more. So using this kit, you can learn how to perform advanced line following with speed and precision, design and create innovative robotics mechanism, build your own machine learning models with the help of this particular kit, and also expand Core Key's capabilities with multiple sensors and motors that will be in this particular kit. So this particular toolkit is to master both the tracks, not just for track 2. This can be purchased for both the tracks. You can directly go on the Codeavour website and take a look at this kit and purchase it from there. So now before moving ahead on the learning resources, let me play a quick video in which you will be able to understand about track 2 and all of its challenges. So allow me a moment to share my screen once again and play the video.
This video is specifically designed for evaluating mission outcomes and scores. It is not to be used to set up the field. For the official field setup, please refer to the field setup guide or video. The Climate Action Challenge is a physical robotics competition. The teams bring their own robot designed and built with Quirky to complete various interactive challenges. Track 2 of Codeavour 6.0 International helps participants develop 21st century skills like coding, robotics concepts, engineering skills, artificial intelligence, strategy planning, and real-world problem solving. In the Climate Action Challenge, your robot will develop, repair, and manage the ecosystem of Harborton. There are 8 challenges, and they can be attempted in any order. You will be scored on all the challenges that your team attempts in a round. The challenges can be attempted either in autonomous or manual mode. Your team can double the score for the same challenge if attempted autonomously. Equipment inspection. Your robot size in its contracted configuration must not exceed 20 by 20 by 20 centimeter and weigh no more than a maximum of 2 kg. Your robot must be a battery operated at the time of competition and voltage must not exceed 5 volts between any terminals of the robot. Start position. At the beginning of the round, your robot must be completely inside the start area. Challenge 1. Protecting the forest. The forest near Harborton is on fire. If trees are lost to disasters, it will be impossible to stop global warming. Your task is to use your robot to unplug the charging dock from the firefighting robot at the nearest fire safety robot launch pad to stop the wildfire in the forest. If the robot is no longer touching the fire safety robot launch pad and charging dock cube is inside the drop point marked with the green outline, you will get full score. If the robot is no longer touching the fire safety robot launch pad and the charging dock cube is partially outside the drop point, you will get half score. Challenge 2. Making roof gardens. Harburton will benefit by adopting green roofs in the industry-ridden areas. Your task is to construct a roof garden with your robot on top of the building. If the cube is fully in the drop point on the building, you will get full score. If the cube is partially outside of the drop point on the building, you will get half score. Challenge 3. Repurposing tires. Repurposing tires provides a potent way to deal with hazardous tire waste more efficiently. Your task is to use your robot to move the used tire cube from the tire service to the eco park to repurpose them to create play equipment for the kids. If the used tires cube is fully in the drop point in the playground, you will get full score. If the used tires cube is partially out of the drop point in the playground, you will get half score. Challenge 4. Reusing battery. Renewable energy plants can utilize repurposed batteries to store the generated power. Your task is to use your robot to transport the used EV battery from the motor garage to the wind farm and replace the expired battery at the substation. If the used battery cube is fully in the drop point in the substation and the cube inside is pushed out and is not crossing the white line marked on the arena, you will get full score. If the used EV battery cube is partially out of the drop point in the substation or the cube inside is pushed out too much and is crossing the white line, you will get half score. Challenge 5. Recycling battery using AI and ML. The increasing number of electronic devices has led to a surge in battery waste. To address this in Harburton, your robot has to collect, sort, and deliver the used batteries to their respective recycling plant. Before the round, the judge will randomly select the expired wet battery cube or expired dry battery cube and place it under the substation, that is, the pickup point. For elementary teams, the judge will randomly select a waste bin 1 or waste bin 2 cube and place it at the pickup point. On completion of challenge 4, the respective cube will be pushed out of the wind power substation by your team's robot. Your task is to use your robot to collect the cube from the wind farm substation. Take it to the camera point and identify its type, whether it is an expired wet battery or an expired dry battery or waste bin 1 or waste bin 2 and deliver it to the respective wet or dry battery recycling plant. If the respective cube is fully in the respective drop point, you will get full score. If the respective cube is partially out of the respective drop point, you will get half score. If the cube is placed at the incorrect drop point, you will get no score. Challenge 6. Enhancing solar cell efficiency. Help Harburton harvest more energy by automating the sun tracking of the solar panels. Your task is to adjust the angle of the solar panel to the west of the arena to follow the sun and enhance solar cell efficiency to boost power production. If the pointer of the panel mount passes the pointer of the panel legs of the solar panel, you will get full score. In case the pointers on both parts are exactly pointing to each other, you will get half score. Challenge 7. Constructing coastal barriers. Harburton plans to lay eco-friendly sediment bags to help safeguard the coastal ecosystems as they help curb global warming. Your task is to use your robot to lay coastal barriers of eco-friendly sediment bags. If all 3 coastal barrier bags are down, you will get full score. If any coastal barrier bag is not down till the end of the round, you will get half score. Challenge 8. Safeguarding aquatic life. Harburton calls upon your skills to perform deep cleanups in the sea for them to efficiently contribute as carbon sinks. Your task is to deploy your robot to clean up the sea by collecting plastic waste and bringing it to the pier. If your robot can get the plastic waste cube to the pier's green zone, you will be rewarded with full score. If your robot can get the plastic waste cube to the pier's yellow zones, you will be rewarded with half score. If any plastic waste cube is partially in the yellow zone and partially in the green zone, it is also half score. Note: judgment will be based on the cube faces only. The hook on the plastic waste cube will be ignored while judging. Participants are required to complete as many challenges as possible within the time limit. The timer will not be paused once the game starts. An unfinished task will not be awarded points once the time expires. Fouls. The team will lose 5 points on each foul. When a challenge is attempted in manual mode. In manual mode, team can access their connected device, but not the robot itself. If a team member touches the robot, it will be resulted in a foul. Case 1. At any instance, if the team wants to touch the robot, the team must prompt the judge for the same and one foul will be called. The team must place the robot back to the last junction that it has crossed in the arena. In the case, robot is in the contact with quirky cube or small cube or unique mechanism or objects, the cube has to be given to the judge or the volunteer to be kept outside the arena. The unique mechanisms must not be touched by the team. This attempt at the challenge will not be scored. The team can further exercise the restore card if available at any point in the time to re-attempt this challenge, and the judge or volunteer will restore the game objects. Case 2. If the robot leaves the track completely, one foul will be called. The robot must be moved back to the last junction that it crossed on the arena. When a challenge is attempted in autonomous mode. In case of a foul in the autonomous mode, the team has to reset their robot at below given robot repositioning points. In autonomous mode, touching either a robot or the controlling device will result in a foul. Case 1. If the team wants to touch the robot or the connected device, the team must prompt the judge for the same. One foul will be called. Team must move the robot by hand to the robot repositioning point nearest to the drop point of the previously attempted challenge. Execute the code to either re-attempt this challenge or another one. In case the quirky cube or small cube of the challenge are held by the robot, the cube has to be given to the judge or the volunteer to be kept outside the arena. The unique mechanisms or objects must not be touched by the team. This attempt at the challenge will not be scored. The team can further exercise the restore card if available at any point of time to re-attempt this challenge, and the judge or volunteer will restore the game objects. Case 2. If the robot leaves the track completely, one foul will be called. Team must move the robot by hand to the robot repositioning point nearest to the drop point of the previously attempted challenge. Additional foul will not be counted for hand touch. Execute the code to either re-attempt this challenge or another one. If the robot has just started from the start or reset point and it has deviated before attempting any challenge, the robot needs to be repositioned at the respective point from which it has started. Additional foul will not be counted for hand touch. Execute the code to either re-attempt this challenge or another one. If a team member touches the robot or game objects without prompting the judge, one foul will be called. The challenge will not be scored. The judge will end the round. Foul shield cards and restore cards that are returned unused at the end of the game will gain an extra 5 bonus points each. Make sure to submit photos, videos, and detailed information about the robot on the Codeavour 6.0 submission portal as per the participation and submission guidelines. Non-adherence to them will result in team disqualification. Remember to read the robot game rule and check for any updates during the season. Good luck!
So that was a detailed video about track 2. So I hope you were able to understand what exactly track 2 is all about. So you don't need to remember everything by heart. This video is just to describe the challenges and fouls a little in detail and help you out to understand them graphically. So now moving ahead with track 2 learning resources. So these are the learning resources that are available on the website. I will be also showcasing one of the QR code that is there for you to scan and access these learning resources. So I hope everything that were explained in this particular session was clear to each and every one of you. If you have any questions, feel free to ask your questions right now. Mr. Dhruv is also here and we will be more than happy to answer your queries. So any questions, anybody, you please feel free to ask right now. I have also presented the QR code that is there in front of your screen to access the learning resources. Can two robots be used here? Mr. Dhruv, would you like to answer this query?
So, yes. So you cannot use two robots, right? But you can use two motors in one robot. So basically the answer is one controller, right? And multiple actuators. This is the answer. For track
Indeed.
2, in track 1, you can do anything.
Right. So you can only use one robot for track 2.
Yeah.
You can use
So your robot
activities
can
in track 1.
expand, right?
Hmm.
If we have a 20 by 20 by 20 centimeter limit in
Right.
length, width, and height, right? So at the starting point, we'll be like examining the robot, whether it's in given dimension or not. But when game starts, once game starts, your robot can expand beyond that point. So if your robot has a scissor mechanism, right, which is contracted before the round, and when round starts, your robot's scissor mechanism go beyond 20 centimeter, right? So this is the possibility you have. So use this possibility, and yeah, complete your challenges very quickly.
Thanks, Mr. Dhruv. So any other questions, if you have, please drop it right now. We will be, of course, having more such sessions. Doubt sessions will be there as well that we will be conducting. The entire Codeavour team is here to support you at any time.
Yeah, there is one more question, that can two worky be used? So in our rules and regulations, we have clearly mentioned that we are only allowing one brain of the robot. So basically one controller only. So only one quirky is allowed for the track 2 for your robot.
Right, Mr. Dhruv. All right, I think we have covered all of the doubts and the questions. So if you have any other doubts, feel free to drop those doubts in the WhatsApp group or over any of the social media platforms where we are. So thank you so much, everybody, for tuning in. Thank you, Mr. Dhruv, for taking this session. It was very engaging and active. Thank you, everybody. We will see you in the next session. Bye bye.
Yeah, thank you everyone.